Hey, welcome back. Good to see you on the bench again. Thanks for joining. Today on the bench I have a CR-820 receiver. This is the same client that brought me the CA-1010 a few months back, and I did a restoration on this. He brought me this receiver. He says he wants the same treatment. He's happy with the CA-1010, and he wants the same massage done to the 820 here, so we're going to oblige. And it looks like a really nice condition. I don't see any. It's a little dirty, don't get me wrong there. It's a little dirty around the buttons and behind the glass it's pretty smoky, but it's pretty much flawless. There's no scratches, there's no gouges, dings, so it's really nice example. It has a vinyl wrap wood case. I don't think there's much damage on this. There's a little nick here, and that's about it. It's pretty nice condition. Yeah, so we're gonna try this one out. He says it does have troubles with pots and switches, just like every other vintage unit of this era. But he said there was something wrong with one of the amplifiers too. I can't remember what he said. It's been sitting here for a month now, and I kind of forgot our conversation. So we're gonna turn it on, try it out. Plug it in first. Going on. Went up to about 60 watts, dropped to about 22, relay clicked. We are on FM tuner right now, but we have... Okay, let's turn the muting off. We've got stereo. Or not stereo, we have both speakers.
323 F-150. Yes, pay no interest at all. With 0%
Right channel, left.
You'll save thousands.
City Ford has these amazing offers. Just
AM tuner. Working good. Audio mute, phono 1, 2. Bass. A little dirty. The mid-range pod's a little dirty. I'm gonna get this off.
Sunny and 6 degrees with a low of -5. 8 degrees with a low of -4.
Loudness pot.
Sunshine on Friday, 7 degrees with an overnight low of -2.
Okay, phono section. Let's. Sounds clean with a little bit of background hiss. Auxiliary, we have a tone. Tone sounds good, both channels. I don't hear any problems with the tone. So it looks pretty much all functioning. So just a matter of going through, and he wants a full recap on this. So we'll see what goes there. And then we'll look for any dodgy transistors, and then we'll clean it up. It might not be exciting here. I don't think we're going to find too many issues with this one. Looks like it's well kept, well cared for, and it works really good just right out of the box here. So, okay, so I took the time, removed the front face, and let's see here. I also removed these 3 struts or supports, structural supports on the bottom. I got full access to all the boards, and I also removed the support for the main filter caps. This is probably going to hit the bin. I don't know what I'll do with this main filter caps yet. I'm going to measure them. If they measure down on value, they're going to come out. What are they? They are 10,000 microfarad, 50 volt. Nothing spectacular. They're Nippon Chemcon. Yeah, all these Nippon Chemcon caps are going to go. I don't know about these though. We're going to test these. But they're easy enough to replace if we have to. We can put 10,000s in there. And now it's just a matter of getting recapping done. I'm really not sure what's going on here. Looks like somebody had a little problem. They fixed it. Okay, so here's a first look without the lid on. So it looks pretty good condition. It's just a little dusty inside. Not bad, but it's not bad. But It's looking really good. I'm pretty sure the original caps are going to be all garbage by now, so I'm not going to try and save any of them. There's no economic reason to save any of these caps. They're all on their way out. They're at that age where they're done. They have to be replaced regardless of the condition. So I'm just going to go through and do a full recap. There's quite a few capacitors in here. As you can see, the tuner's stuffed with them, and the power supply, the tone board has quite a few. Okay, looking on the bottom side of this, this is the power amplifier here. Looking quite a few cracked solder joints on a lot of these transistors. So I'm wondering, there might be some intermittent faults that come and go. And I can see right here there's a voltage regulator transistor here, series pass, and it's got cracks on two of the joints. This joint's cracked, and this joint's cracked. Looks like, I don't know if you can see that. I don't know if you can see this crack. Probably not. Anyways, I'll get started with the cleaning, and we'll start recap. We've also got some problems here with these two plastic. All they're there to do is keep the range, but they're cracked here, the set screws in this. This one's cracked as well, both sides. So eventually that'll just fall apart. And I wonder if I take some measurements, maybe I can recreate these with a 3D printer, but I'm not going to put any hope in it. But I'm just going to leave that alone. I'm not going to play with that. I don't want to disturb this. It's holding together. Maybe what I'll do is I'll... oh, it's hard. The set screws are here on the side, here and here. I was thinking maybe I could wrap it and epoxy it, but then the set screws won't be accessible unless you cut the fibers out. Alright, I pulled the first capacitor, and this is what I'm greeted with. So this is a 1000 microfarad 50 volts, and it reads at 536 microfarad. Take a look at the specs on this thing. It's 85 degrees, ESR is 195. That should be a lot lower than that, but our capacitance is way out to whack. So I'm going to go through and replace some of these caps. I'm going to replace them all actually, and then I test every one as I take it out, and I get a good indication of how the caps have held up. But so far, not very good. Okay, the recapping's done. It took me well, it took me an entire afternoon to get the entire thing recapped. I went through one cap at a time. I didn't go crazy. I just took my time, did one cap at a time, pulled them out, test the cap, replace it. And I usually do that when there's a lot of different values and it gets really complicated. I don't want to screw anything up mixing up caps. Really surprised that the quality of these caps are garbage. Some of these caps here, like for example these 100 microfarad caps measure at 20 microfarad. These are the Mashashita ones. They're not leaking, but they're all dead. A small percentage of them held up. I'd say maybe 20-15% were still good. The rest of them were all crap and garbage. I'm surprised this thing even worked the way the caps were looking in this thing. So I pulled out the big ones, the main caps. These are 10,000, and I'm going to test these right now. We can test them together and we'll see. I think they're going to get replaced as well. Nippon Chemicon, not having much faith in their brand right about now after what I saw. Everything 2.2 microfarad and less gets replaced with a film, and I do that for reliability. I don't do that for changing sound or any of that BS. I'm not convinced that replacing a 1 microfarad electrolytic with a 1 microfarad film cap will change the audio so much that it'll make it objectionable. I don't think it changes the audio at all, to tell you the truth. So that's my thinking of it. I did the tone board. That went well. It's still sitting in here loose. took the pots out and cleaned those pots as well, recapped it, and I replaced 2 transistors on the tone board. I still have lots of transistors to replace here. I can see that the whole thing's littered with them. Where are we? For example, this one here is a 2SA-844, and we got some other ones here. Not so many on the amplifier, but more in the tuner, and I'll get to that later. Yeah, let's test these caps. Okay, so here's the first one. Where are we here? A blank, B, C. I need C and the negative. So I guess this one here. This one and this one. So this comes back at 7,700. Oh, it's actually jumping around quite a bit. Maybe my connection's poor. Get a good connection on this. So we're getting about 7,800 microfarads back, which is down almost 25%. Okay, let's try this one. And this one here. Pretty much the same thing. Well, I don't know why I'm getting erratic readings here. I must have a poor connection. 7,800 as well. So we're going to replace these 2. They're more than 20% out. And let's see what we got in stock here. So I've got 10,000 microfarad at 50 volts, same voltage, same value. And what I'm going to do is I'm going to install them right in the same location. I can reuse one hole, but I'll have to drill another hole because these have totally different pin spacing. These are 10 millimeter, and the old ones I think are 25. Let me check. Pin spacing on the old ones are, yeah, 25 exactly. So I'll have to drill a hole for each cap, and I can do that easy enough. This one here will fit like that. It'll be offset with the silk screening, but that's okay. As long as they're both in there. I might have to move these diodes away a little bit because they might rub. Yeah, that'll work. Can plug that in there, drill one hole here, and make it work. Okay, I got the 2 new holes drilled, one here and one here. I don't know if you can see them. I made they were 60 thousandths of an inch, and I measured the lugs on these, and they were just shy of 60 thousandths, so that's why I picked 60 thousand. So let's see if this fits. It should fit. Get it in. There we go. Yeah, that's going to be perfect. Let's see here. Positive up. Yep. On the other side, I need to scrape away the solder mask here for the solder pad, make a new solder pad. These ones I'll fill with blank them over with solder, and they won't be a problem. Another thing I'll do is I'll use adhesive, and these 2 caps will get glued down to the board. Okay, update time. So I'm done recapping. Recapping's all done and complete. And another thing I did is yesterday I took the time and I pulled all the transistors out of this unit and tested them. Now, here's a sheet of my notes. Now, what I do is I pull out each transistor and test them for gain, HFE, beta. Now, the reason I'm doing that is not because I'm looking for bad well, I am looking for bad transistors, but I'm looking for outliers. So if you have a certain amount of transistors that all have the same gain, you know that they're still in good condition. But when you have an outlier, then you know you got a problem. For example, after I did this, I had 3 outliers. One of them is right here, Q505, and it was a 2SC1213, and it came back with a beta of 47. Now typically the 2SC1213s have a beta of around 150. Here's a 141. I think I got a couple more here somewhere. Where are they? Yeah, right here. 1213s. This one's a 151, that's a 146. So if you get 141, 146, 151, those are all grouped in the same area of beta, and you can make the assumption that they're okay. But when you have an outlier that has 47, you know that's a problem transistor. Now, all of these 2SC1213s were replaced with KSC 1845, so that's not a problem. That was eliminated right off the bat. I found another outlier here, is Q304, and it's a 2SC 1918, and it came back with a beta of only 282. Typically, the beta of the 2SC 1918s is around 425, and I could see it here many times. 425 here, 425, 425. If I look here, 425. Those are the norms, and then here's our outlier is 282. So I'm probably going to replace Q304. Even though it's not a critical transistor, it's in the FM circuits, and I think it just does something to the effect of switching on the stereo amp, for example. I'm not sure on that, so don't quote me. But we're going to change that one as well, the 2SC 1918. And then there was a third outlier up here, Q720. It's a 2SC 1624. This is the NPN driver transistor for the output devices. It came back with a gain of 102. Now the one in the other channel had 139, which is more acceptable. Now the gain range for this transistor is Y, so that rank should put it somewhere between 120 and 240, and we're falling out of that on the 102. So this transistor here is going to get replaced. Now, I just can't replace one transistor here though, because these are working in complementary pairs. So I'd have to replace the PNP equivalent as well, which tested out fine. Probably what I'm going to do is I'm going to replace all 4 of these driver transistors. Only one of them is bad. I'm going to replace all 4 of them. And I'm going to use 2SC 2073s and 2SA 940s as the complement. And I'll put those in, and we'll see how that runs. These ones have a little lower gain. Oops, I'm throwing transistors everywhere. These ones have a little lower gain, but they're brand new and they're more suitably matched to each other. So that's my thinking behind that. Now the same goes for the output devices. I'll be taking these out and testing their HFE on these. I don't expect I'll find any that are that far out, but if I do see anything that's really out to lunch, I can also consider replacing these transistors as well. Alright, let's do a little bit of relay roulette, everybody's favorite sequence. So let's try this. This is freshly pulled out, pulled the cap off, 12 volt DC relay. Where is the cap? Here's the cap if you want to look at the part numbers. Get a good... Okay, so let's see. You should be able to see my meter up on the... Let's check normally closed here. What is this one? Okay. On this one we got 16 milliohms. That's pretty good actually. That's not bad for a relay I haven't touched yet. Here is the other channel. 85 milliohms. That's a little worse. Okay, so let's put our meter on there and let's test this coil. 12 volts here. Let's see what we get. 15, 16 milliohms. That's actually pretty good. I'm surprised. So from that tells me that the owner hasn't been getting any problems from this relay, any dropouts. Let's try this channel. 168, that one's a lot worse. 100, 200, 40. And if I work it, it'll go down, right? Okay. Let's have a look at these contacts. I don't even remember looking at them yet. Yeah, they're not bad actually. There's not too much tarnish on these ones. You can see the pads in here. They're actually not bad. Okay, I'm going to polish this up and then put it back together. We'll test it one more time. Alright, here we are post cleaning. So let's check this out. What do we got here on this? Okay, so normally open, or sorry, normally closed, 8 milliohms, which is very good. Other channel, 8 milliohms. Okay, let's test the normally open contacts. Eight milliohms. Last one. 8 milliohms. So eight's all around. Looks so good. Okay, I'm going to put this back in, and we're going to which way does this go? I don't think it goes like that. It goes like this. Yeah. Okay, I'll put that back in. And I think we're going to move on to testing because I'm pretty much done. Okay, traps and pitfalls for the new players. This is one I just fell into, and I'm just going to tell you guys about it so you don't make the same mistake. Did an initial power up on this. Powered it up. It went, climbed to about 50 some watts, then went down to about 13 watts and stayed there. The relay would not kick in. I says, oh great, now I got a fault to troubleshoot. So I started pulling out printing schematics and pulling out drawings, and I was doing some checking around on the power amplifier. What I had on the speaker output line here, I had about 6 or 7 volts DC on both of these. So I'm thinking, okay, something's not right within the amplifier, but it's affecting both channels, and they're both equal, and they're affected the same. So we don't have like a bad component in one channel or the other. It's something globally. So I started looking at this, and then I went back to this circuit here. I started looking at this. Pretty much everything on the right of this here. Let's draw a line. Pretty much everything on the right of this here is powered through the main filters and the rails. Everything on the left hand side here comes from a separate power supply, and you can see the long tail pair here, and it's powered by a plus 30 line here, and I don't know if it has a minus 30 line. It might have a minus 30. Well, I got minus 42 here, but that might be part of this. Okay, so anyways, a 6 volt, 7 volt offset on the output tells me something's not balanced. So I went here and started checking voltages, and I didn't have my plus 30. Surprise, surprise. Okay, let's go back to the power supply. Power supply, I went, this is the main pass transistor. I checked, I have, I can't remember with my values now. I had them in my head, but now they're gone. But anyways, I look and I see this ground symbol here. And I'm thinking, oh, you know what? we might have an open ground, because I have done a few things here that didn't when I was doing my work. So what was going on, make a long story short, and if you can see this, I was powering up this receiver without this bar in place, and this bar provides ground points at 4 locations on the tuner board and the main board. So I put the bar back in, tightened all the screws down, and now we have problem solved. So let's start it up. There's our relay, click, drawing 20 watts at idle, and everything looks like it's a go. I still haven't touched any switches. Another thing I'm going to do is I'm going to evaluate these 2 switches here. I might yank them out and clean them if they're dirty, but I'm finding on this receiver the oxidation isn't too bad. Like, the relay wasn't bad, the potentiometers weren't too bad, the switches, they were behaving on my initial test as well. So I'd rather not do anything to the switches if I don't have to, but comes down to it, I will. So now we have a working amplifier. I'm going to address the lamps next. I'm going to get some LEDs in this place, and we're going to get this thing finished up. Alright, so I finished the LED retrofit, and here's a look at how it shines up. It's not very bright, I know that, but once you put it in the case, and it will shine a little brighter than that. It's quite... Let me turn it off again, show you the difference from between on and off. Now, what I've done is essentially replace these 3 bulbs with LEDs, and I use the same wires and the same rubber socket thing here. Pull one out and show you. Ooh, that really wedged in there. It is just an LED. Warm white LED that has incandescent glow to it, and that's the color I want, because there are color filters in here and a color filter in here to make it look like kind of green. But I don't know, Yamaha really missed the mark on that one. So anyways, what I did, like I said, used the original wires for the original look, and you can't really tell it's been upgraded to LEDs. I used the same posts. Let me shut this off. There are 4 posts here labeled L1, L2, L3, and L4, and those are the connections for the lamps. One of the connections, I think it is, let's see, which one was it? I think L1 was the positive connection and L4 was the negative. Okay, because there's a cap right here that filters it. Now I measured this. This is plus 22.4 volts DC. It's rectified, filtered, and that's what I used for my calculations. These 3 LEDs here are wired in series, and they all terminate back onto here, these posts. And underneath this board, you can't see it now because I have the strut on the bottom. Under this post, under these posts, there's a 2.7K chip resistor. That's our dropping resistor for those 3 LEDs. Now the LED for the dial pointer is on its own circuit, goes in, and it's connected to another post here, L3 and L4. And L3 and L4 has a dropping resistor of 4.7K. So that limits the current down to about 4 milliamps. Current in these are about 5 milliamps. So that's my explanation on how that goes together. And like I said, you can't, if you want to look at it, you can't tell it's been retrofitted. The chip resistors are on the bottom. You can't see them. It's covered by a plate. So it looks pretty natural. Okay, so I'm going to move on to the bias adjustment. And here's our adjustment points. VR702, 701 for left and right. Test points are not that easy to get to Well, they are actually. They made it easier for us. They want us to measure on one channel, the right channel. We measure on test point 3 and test point 4, which is on both emitters of the output transistors. Now, since we are the other transistors are blocked under here, you can't, by the transformer, you can't connect anything to them. So what they did is they brought out test points. You can see them here. There's 2 test points, one right here and one right here. Test point 1 and 2. And that's where you connect your leads rather than trying to clip them on underneath here. And it shows it on this too. They have test point 1 and 2 for this side. So we're going to connect the voltmeter and power this up. Now the spec is kind of unusual. It's really low, 8 millivolts across both test point 1 and 2 and 3 and 4. So you're measuring across both emitter resistors. And you're only getting 8 millivolts, which is really low in my opinion, but whatever works for them, I guess. So let's try 1 and 2 first. Clip these on, and we'll turn this thing on, and we'll see where we are at. Okay, can you see the meter? There you go. Okay, turning it on. And this is on a millivolt scale. Oops. No, I don't want that. Let's try this again. Millivolts. We are down pretty much non-existent. We're less than 1 millivolt. So I'm going to let this sit for probably 10-15 minutes, and then I'll come back and we'll do the adjustment. So it's very slowly coming up. We're at half a millivolt now. And we're down 21 watts consumption. That's really low. Let's turn this up. See if we can get this to 8 millivolts. Okay, I'm going to leave it there for a while, let it stabilize. And we're at 24 watts consumption now. I've only done the 1 channel yet, so this thing's stone cold, and I expect it's going to start warming up. See, it's already at 10 and climbing, so I'm going to turn this down a bit. Got a little too far. Okay, we'll let that settle, and I'll keep adjusting it, then we'll do the other channel. Yeah, so I step away for a few minutes and all hell breaks loose. Look at this, 29 millivolts, climbed up to 35 watts. So it's very sensitive adjustment. We have to turn this down. Probably going to end up right back where I started. We'll take it, tone this down to about 8 again, 7 or 8. Then I'll work on the other channel. Swap leads to the other channel, and we'll see what we got there. .9. I smell something getting hot. Yeah, that's quite warm. Turn this one up a little bit. Turn 6, and we'll sit on that, and we'll watch that one rise up too. There it goes. Seems like once it warms up, it really wants to run away. Okay, I got this all lined up, and this is our consumption after it's set. So that's what it should be around. Alright, time to move on. Alright, so wired in for a power test. Ready to do it. We got our 8 ohm load back here. Voltmeter connected. Scope is connected. We're feeding it a 1000 hertz tone from the signal generator. I got it fed into the phono inputs right now. I want to test the phono stages. Now, I did have a problem on power up, and that really kind of threw me for a loop here. Powered it up, I had no right channel, and when I did turn it up the volume, I heard a little squeak of a noise come out of the right channel, and then boop, it went away. I said, oh God, was that a transistor that just went, or what? Blew a resistor or something? And then it was total silence out of that right channel. I couldn't get it to come back. So what I did, I got my scope out and I started poking around and checked the inputs of both channels. They both had signal. Then I went directly to the driver stage of the transistors and checked those. They both had signal. I said, well, what's going on here? There's signals getting through the amplifier, but no signal getting out to the speakers. So I was playing with the switches, and then I gave the little relay a tap, bang, and there came back my channel. So assuming I have a dirty relay still, I might have to revisit that. So let's turn this on. Let's see what I got here. I got that is, that's my scope channel. This is my speakers. Okay, let's turn this on. Okay, here's our click. Full volume is nothing. Okay. Here's our, ooh, see? And it just clicked off. I have it on full rate right now, full rate. You can't see. I turned it up. See, that relay is still, try that again. Yeah, it is flaky, so I'm gonna have to redo that relay. Probably just need cleaning. Anyways, we have our signal coming out the right channel. Let's center the balance. And I got this all set up weird. Okay. Okay, so there's our, let's turn off our speakers. And we should still see our signal on the scope. Let's take it up to clipping. I might have to go a little farther here with my, that's full power. Oh, I'm still on phono. Okay. Let me switch the inputs around to the auxiliary and then we'll try this again. Now that I know the phono is working. Okay, now we're fed into auxiliary. Let's see here. Where is it? Oh, there it is. Alright, let's go up. Here's our clipping. Let's take it back down. Let's set it right there for now. And let's get our timer going. Okay, hang on here. We got a problem. We don't have anything. Yeah, I got my speakers connected. Let me disconnect the speakers. I had my speakers connected to the wrong channel. Okay, let's just leave that out for now. Let's see what we got on our dummy load now. There we go. Now we're starting to get, ooh. That does not look good. We have a problem, Houston. Some kind of really odd distortion. Okay, what do we got? We got 21.34 volts RMS. Let's see how this thing survives. It's got a really... It actually didn't go into clipping, it just went into distortion. So something's really not right with this amplifier. I'm wondering if maybe it's my substitution of transistors. Kind of highly doubt it though. We'll let this cook for 10 minutes and we'll see how that behaves. Okay, we're at the 5-minute mark. This is what I'm consuming at full power, 238 watts for both channels, and I'm delivering right now at 22.66 volts RMS, and I think that works out to, let me work that out here, that works out to 63.8 watts per channel. This is only 50 watt per channel amplifier, and it's doing 68 or 63, so it's achieving its objectives, and it's working pretty good. It's starting to warm up a little bit, not bad. I'm starting to smell some hot stuff going on around here, but let's check the heat sink. Right now we're at 40. We're in the 40 range for the heatsink, which is still pretty cool. Gonna let this go for a while. Okay, we're coming up to the 10-minute mark now, and things are warming up. We're at 50. Let's see here. What are we at here? We're at 50, 56. That's the maximum we're reading right now. 58 degrees Celsius. These are starting to warm up a little bit. For the most part, we're doing okay. We're doing okay. And it didn't blow up, that's the main thing. And our my heat sink, on the other hand, is not doing okay. It's over 140 degrees Celsius, so it's way too hot. Let's shut this down and let's look at some square waves. I'm gonna let this cool off for a bit first, and then we'll get some square waves going. Okay, we're back. Got the square waves installed. Let's get a little bit of a signal in here. We don't want to go crazy. So that's bass cut, bass boost. Not looking too promising. Mid-range cut, mid-range boost. Treble cut, treble boost. I wonder why do we have a tone defeat on this thing? Okay, here's a look at the signal. The top trace is the signal coming out of the preamplifier going into the power amp, and the bottom signal is the signal coming out of the power amplifier. So you can see there's quite a bit of difference. Plus there's some jittery going on there on the bottom trace. That is on the output of the amplifier, so something's really not right with this amplifier. And from what it, see, sometimes it goes into protect when I turn the volume up and down. Try and trigger that again. Oh well. Sometimes it does it, sometimes it doesn't. But anyways, that bottom trace doesn't look good at all. That's coming out of the power amp. And top trace is what's going in. That's my point. So let's dig deeper into this. Let's see. There it clicked off again. Let's have a look at the circuit. Okay, so this is the front end of the power amplifier board. This is the signal I was tapping off and measuring off these two connections here. And it goes through a series of capacitors we got 1, 2, 3, 4 capacitors before it hits the long tail pair. And then it has all these tone circuit controls in it. It's got your loudness control right here. This is a variable potentiometer with some attenuation. And then we have low filter. There's 2 switches here though. Why is there 2 switches? One's a low filter, one's a high filter? No, they're both the same. Okay. So it's all low filter. And then it gets into the transformer. So between here and the output back here, right here, we're getting some kind of distortion. I just want to check. I guess what I can do is I have the signal path here. I can follow it through with my scope and I can see where it's going corrupt. And maybe I'll do that next. I replaced 711 and 712. And then I replaced 720, 722, 721, and 719. What I can do is I can pop the old transistors back in and see if it changes on that one channel. But first I'm just going to try poking around the scope, see if I can find a reason why it's doing this. Okay, so what I've done is I replaced both driver transistors in one channel only. I put the old ones back in, took out the new ones, my substitutes, and put the old ones back in. And this test is just to confirm it's not those transistors. So turn this thing on. I'm going to plug it in first. Plug it in, turn it on. Here we go. Relay click. And we have a square wave on the output. What the hell? I'm also not running a load. So let me put a load on. Okay, load is on. What is going on here? Was I getting feedback before? Now it's working. Left channel, right channel. They're both equal. They're not distorted. That's the loudness, treble, mid-range, bass. That's really odd. Okay, we're back for round 2 of the square wave test. Now, I'm pretty sure I had a ground loop somewhere that was causing the distortion. I've had this happen before, especially when you're doing phono stage tests. You get a ground loop, it really messes up the input signal. For right now, I don't know what caused that, because I took out some transistors, put old ones back in, and everything was working fine. So I took those out, put the new transistors back in, everything's working fine. So let's try this one more time here. I got it powered up, I believe. And turn this up. You can see the square wave now. And we're getting, we're on 2 volts of division, so we're not going to pump that much power. Let's turn this down a bit. You just want to see it, not hear it. Or smell it. Okay, so there's our square wave. Bass cut, bass boost, starting to look normal. 1, 2, 3, 4, 5. Mid-range cut, mid-range boost. Okay, 1, 2, 3, 4, 5. Treble cut, treble boost. 1, 2, 3. 1, 2, 3, 4, 5. Okay, and this is the loudness control. It's a fully clockwise right now. Start turning it counterclockwise. You see the signal drops, and we start getting coloration. That's minimum, that's maximum. Okay, good enough. Balance control's working nice. Volume. Okay, let's go up in frequency. What are we at now? We're at 1 kilohertz. What is that? 7 kilohertz. 8, 9, 10. That's what 10 kilohertz looks like. Not too bad. It's doing okay. Let's keep going. I'm starting to lose it right about here somewhere. And that is 23, 24 kilohertz. Keep going and going and going. That's 50 kilohertz square wave. So it's actually holding its own pretty good. It's not doing too bad. I've seen a lot worse and I've seen better, but it's doing pretty good. Go back down. One kilohertz. There it is. Alright, let's have a scan through the band. So that'd be speaker A, power, plug it in. Power. And we are on FM. Okay, so let's see how this works. There's a weak one right there. There's another weak one. We're not getting very good.
Catherine Brodade, vous êtes là?
There's a good strong one.
Allô, est-ce que vous êtes...
Oui.
Oui.
Now take a look around. What room would you say is the heart of your home? Because a new survey asked this very question, and I'm going to tell you.
It's working pretty good. It's a little weak in the reception. It's having difficulty. I have a good antenna connected, and it should be bang, bang, bang all these strong stations, but it seems to have a little trouble. That one was only at 30%.
When you're working so hard.
It's pulling in stereo. It's 60%.
Spent a fortune of around $650 million. All right, Bobby, please answer.
Hello.
Hello, Bobby. It's Colleen Troy from Up 99.3.
The radio stations are having a big giveaway contest because nobody's listening to them anymore. You notice as I grabbed the knob here and the FM stereo, I think you can see it on top. Everything's working. There's some high power ones on top here. Okay, let's check out AM band. And quite a bit of interference.
The pivot she thought she'd never make.
There's only one good station there so far. Should be picking them all up. I'm probably going to go through doing an AM/FM alignment. I think it probably needs it. It seems like it's just not performing the way it should. So I'm going to try going through that off camera, and we'll see how I get results. If I get any results, I'll let you know. If it's no big deal, I'll let you know either way. So I'm getting just over 1.1%. So we're on the 0.3% scale. So you're reading the top red one, and it's resting right on the 1. So 0.1% harmonic distortion. Okay, so it says it should have a usable sensitivity at 98 megahertz. Okay, at IHF mono, 1.8 microvolts. Okay, I'm feeding it on the 75 ohm line right now. No, actually I'm doing the 300. So it'd be 1.8. And 1.5 mono stereo 50. Alright, so I got it set for 40 kilohertz deviation, 98 megahertz. This is how many microvolts it is right now. Let's turn this down. Yeah. Kind of a dicky connection maybe. I don't know. So he's kind of losing it right there. Yeah, it's not going down as low as it should. Yeah, and it also says 50 microvolts for stereo. So I'm in stereo now. It is on a stereo signal. And we're at 50 microvolts. Let's turn this down until we lose stereo. There we go there. Yeah, 18.5. Okay, so this is all hazardous back here. All this mains wiring is exposed. You got the 3 sockets. So don't be sticking your fingers back here. And then for whatever stupid reason they have a mains wire running to the main board here. That's where the fuse is located. I really don't like that. You know what I might do? I might just reinstall a fuse holder here somewhere on the back. Off that board. Let's see here. Go right here. Right here I can drill a hole and put a screw. It won't bother any of the graphics. Well, there you have it. I managed to lock out and get these two screws to align properly. It looks kind of cool. I didn't expect that, but it covers your fingers from getting zapped. Anyways, I could put a sticker on there too. It's a lot better than having the wires going to the main board. Okay, I finished dressing this and then I'll put it back in the cabinet. Okay, well that's it for this one. It's all back together, back in its case, looking good. I did go through tuner alignments and I gotta say it was pretty much spot on. I didn't see any. I actually made one little adjustment that moved the dial maybe a millimeter over. Everything else was on spot on, so I left it alone. And it is picking up stations. I don't know if it has a problem with the front end or not. I was going through a 75 ohm coax into a 300 ohm transformer onto the back of the unit, and then on the back of the unit there's another 300 ohm transformer that transfers it back to 75 ohms before it goes into the tuner front end. So there's two transformers there that are probably attenuating the signal that don't need to be. If I just fed a signal straight in on the 75 ohm, it would go straight to the tuner and there'd be no problem. But you can see it's having a little struggle here pulling FM stereo on that one channel, and it's fairly weak too. It's only at about 12 or 15% on the meter here. It's fairly weak, but it sounds good and it's working, and everything else is working good. The big story for this one was bad caps. Now I do remember the client bringing this in and he says one channel sounds not the same as the other. He said one channel sounded good, the other sounded pretty, it's lacking in something. He couldn't describe it because, you know, when you get bad caps, you lose your brilliance and your clarity and your frequency response, and you lose a lot of things in your audio, and it's really hard to describe just what's happening to the sound just when you get a bad cap in the series. It really muffles and almost attenuates. So best thing to do in an old receiver like this is just go through, strip out all the old caps, put in brand new ones, and then start troubleshooting. Don't waste your time trying to troubleshoot problems on an old receiver when it's filled with old caps. It's just a waste of your time. So this is all back together. I'm going to listen to it for a couple weeks, and then I'll call up my client and say, come pick it up please, and everything's good. So thanks for watching. Talk to you later. Got more stuff coming up, and we'll see you on the next one. Bye.